Hello friends, now we'll think about part 4, electric potential, part 4. In this part, we'll discuss very important numericals, MCQs. But before moving towards the next point, first of all, we'll revise the story. Few points we have discussed, particularly for this electric potential. And this is the lecture number 4. So you know that very well. First of all, what is the electric potential? Electric potential, that means the work done per unit charge. So V is equal to W by Q. In terms of potential difference, delta V is equal to W by Q. You know that. So this one is the formula number 1, 2. Number 3. You know that very well. Potential difference between 2 points. If you think about potential difference between 2 points, that is, suppose potential difference between 2 points AB. So VAB is equal to VA minus VB is equal to minus B2A E dot dr. Ready? So very important point. Here potential at point A with respect to point B. You know that. What is the meaning of this point? Potential at point A with respect to B, it is also called work done required in moving unit positive charge from point A to B. Last time we discussed numericals based on these 2 points. Today we will also discuss one more based on January 2019. But before moving towards the next point, fourth number, you know that very well. Fourth number, what is the formula? Potential due to a point charge, single charge. What is the potential? Potential due to point charge is given by equation KQ by R, most IMP formula. So today, most of numericals based on this formula, potential due to point charge. So we'll start with, we can say that some basic concept, just concentration required. Suppose there is a charge. Let the magnitude of this charge is 4 into 10 raised to minus 7 coulomb. Now, because of this charge, I would like to find potential at this point P. Let the distance of this point P, it is 9 centimeter. So, what is the potential at point P? Because of this 4 into 10 raised to minus 7 coulomb charge. So, very easy. Here distance R given, charge given. So I can write potential at point P. It is KQ by R. What is the K? You know that 9 into 10 raised to 9. Q, 4 into 10 raised to minus 7. And R already 9 centimeters. So 9 into 10 raised to minus 2 meter. 9 cancel. So what's the formula or answer of V? It is obviously 4 into minus to get transfer. So it becomes minus 5, and minus 5 plus 9, that means 4 into 10 raised to minus 4 coulomb. Sorry, yes, 4 into 10 raised to minus 11 minus 7, 4, but plus 4 coulomb, obviously. So 4 into 10 raised to 4 coulomb answer. Just check it. K is equal to 9 into 10 raised to 9. Here charge given 4 into 10 raised to minus 7. And 9 centimeter away, so 9 into 10 raised to minus 2. So very easy. But one more question included in this given question. What is the next question? So one point is clear. What is the potential at this point P because of this charge Q? This is the potential. And answer here in terms of volt. There is a mistake because potential then volt. So 4 into 10 raised to 4 volt potential is produced at this point P. Now one more question is given. Suppose at infinite distance there is another charge. It is 2 into 10 raised to minus 9 coulomb. So what's the question? Now this question you have to solve. You can take some time, don't worry. So you can see at infinite distance there is a charge 2 into 10 raised to minus 9 coulomb. We would like to move this charge. 2 into 10 raised to minus 9 coulomb charge is situated at infinite distance. We would like to move this charge from infinite to this point P. which is situated distance 9 centimeter from this 4 into 10 raised to minus 7 coulomb charge. So what is the work done required? So what's the question? Calculate the work done. Work done required in moving this 2 into 10 raised to minus 9 coulomb charge from infinite to this point P. Apply your logic if you have. Take your time, don't worry. Okay, so you can see we'll try to solve it. Most of students have done it, but now whatever your answer is it right or not wrong, we'll check it. So there is 2 into 10 raised minus 9 coulomb charge. We would like to move this charge from infinite to point P. Obviously we have to do some work. So work done W, that's your target. But we have already idea about the potential at point P. What is the potential at point P? Because of this charge, whatever the potential is produced, it can be found already. Sorry, we have already found 4 into 10 raised to 4. So potential already at this point P with us. So what is the general formula of potential? Work done per charge. So it implies that work done is equal to charge multiplied by potential. So work done, what is the charge? We would like to move 2 into 10 raised to minus 9 into potential at point P. What is the potential at point P? Already we have found 4 into 10 raised to 4. So if you simplify, so 4 2 ja 8, 8 into 10 raised to minus 5 joule. So this amount of work is needed to move this charge from 2 into 10 raised to minus 9 coulomb to, we can say that at point P. So this is the very interesting point. One more question also associated with it, but we'll discuss in the next segment, don't worry. So this is your illustration number 2.1. First illustration we have discussed in your textbook. This is your first illustration. Keep in mind this type of question can also become a part of your board examination paper. So don't forget, no doubt very easy, but sometimes they ask this type of very easy question. Don't forget this question is already asked in board exam. Okay, so very IMP, illustration number 2.1. Now you think about one more. Very easy, no doubt, work done, very important, Q into potential. Now the second point is very important. So whatever the point I will discuss, it is very important. Why? Because this type of question can also become part of your, we can say, the NEET. So just concentration required. There are, you can see, two charges, Q1 and Q2. Q1 already 5 into 10 raised to minus 8 coulomb and Q2 3 into 10 raised to minus 8 coulomb. Second charge already negative, you can see. This both charges separated by distance 16 centimeter. So two charges separated by distance 16 centimeter. They both are, we can say, that joined by using this line. This is the line joining these two charges. What's the question? Your question to, we can say that find. Your question to find the potential, or I can say the potential not, but I can say the point at which potential due to these two charges becomes zero. So what's the exact question? Calculate the point or position, or I can say the find or determine the point or position on the line joining these two charges at which electric potential because of these two charges becomes zero. So now we will first of all consider first part. I will, we can say, the explain, and then second part you have to perform at your home. So we consider, suppose this one is the point P where electric potential becomes 0. Here V is equal to 0. Let the distance of this point P from this first charge is x, and the distance, obviously distance of this point P from the second charge now 16 minus x, because the total distance 16. So we would like to find potential at this point P. Already we know that potential here is 0. So as per given condition, total potential at point P is V is equal to 0. But what is the, we can say the total potential? Total potential at point P is suppose V. So I can write V is equal to V1 plus V2. V is the total potential, not the total potential here 0. But here potential is mainly produced due to these two charges, Q1 and Q2. Let the potential at point P because of Q1 charge is V1, and potential at point P because of this Q2 charge is V2. But total potential at point P is 0. So V1 plus V2. So I can write V1 is equal to minus V2. Now V1, what is the V1? V1 is the potential at point P because of this Q1 charge. Tell me what is the formula of potential at point P or at any point because of point like charge Q. What's the answer? KQ by R, you know that. So here V1, so it is KQ1 upon R1. What is the distance of this point P from charge Q1? This distance, it is X. So KQ1 upon X minus V2. What is the potential at point P because of this Q2 charge? Once again, potential due to point charge KQ upon R. What is the distance of point P from Q2? This distance 16 minus X. K cancel. Here Q1, it is 5 into 10 raised to minus 8. X, your target. Here Q2 already minus 3 into 10 raised to minus 8. And 16 minus X. Now, definitely here, if you think about simplification, then very easy. Now this 5 multiplied to 16 minus X cross multiplication, and 3 multiplied to X. Ready. So now 16 5 is 80, and there is 5x, 3x. So 80 is equal to 5x plus 3x because minus becomes plus. So 8x. So x is equal to 18 by 8, 10 centimeter. So one point is clear. This point P is situated at a distance of 10 centimeter from this Q1 charge, and at a distance 6 centimeter from this charge Q2. Ready? So this is the first part of this numerical. This is very important. एक साथ दोस्तों हमने दो न्यूमेरिकल्स कवर किए हैं, एक अनसोल हो गया और एक इलास्ट्रेशन. कौन सा अनसोल है कौन सा इलास्ट्रेशन we'll discuss later, but this is the methodology. But what happened here? Here, whenever you are discussing for neutral point for potential, it is called zero potential point. Then there are two cases. Here I have discussed for internal points. That means whatever the zero potential point, it is between two charges. This is called internal point. Similarly, you can think about external. That means this point is situated somewhere outside of these two charges. Okay, and it is always close towards, we can say that, small magnitude charge. Here two charges, small magnitude charge -3. So obviously we have to consider second, or I can say external point, just close to this Q2 but outside. We'll discuss. But this is the methodology. You can see that for first, this is your unsolved number 2.1, textbook unsolved number 2.1. Now you have to solve yourself second part. Okay, second part है वो आपको अपने आप ट्राई करना है, मगर मैं इसके जैसा एक और न्यूमेरिकल देता हूँ जो आपको ट्राई करना, मगर उससे पहले थोड़ा एक्सटर्नल पार्ट का भी डिस्कशन कर लेते हैं. फॉर इंटरनल पॉइंट्स, नाउ फॉर external point, suppose these are the two charges Q1, Q2 separated by distance 16 centimeter, and this is your zero potential point P. At the distance of this zero potential point P from this Q2 charge, small magnitude charge, it is y. So obviously this distance 16 plus y. So what is the total potential at point P? Total potential at point P, it is V is equal to V1 plus V2. But we know that total potential at point P is already 0. So 0 is equal to V1 plus V2. So again V1 is equal to minus V2. Now you have to set up the formula and you have to think about some mathematical simplification and try to obtain the answer. Okay, this is your answer number 2.1. Internal point I have discussed, external point you have to solve yourself. Okay, and at present time you can also solve. Take your time, don't worry. Take your time, 1 or 2 minutes, don't worry. Start. Okay, so now you think about this solution. So V1 and V2. So you have to solve yourself now. V1 KQ1 upon R1, V2 KQ2 upon R1. Here you can see that 16 plus Y, while here KQ2 upon Y. Set up the values and your answer should be 40 centimeter. If you obtain answer 40 centimeter, then no problem at all. There is J double init concept also, but we will discuss after completion of few more numericals. So one more numerical from my side, you have to solve at your home. Okay, so once again these are the two charges Q1, Q2 separated by 15 centimeter. Q1 here already 2 into, just a minute, here Q1 already 2 into 10 raised to minus 8 coulomb, sorry, 3 into 10 raised to minus 8 coulomb, and here minus 2 into 10 raised to minus 8 coulomb. Separated by 15 centimeter, you have to solve yourself. This is illustration number 2.2. Illustration number 2.2. If there is mistake in data, so you have to improve yourself. Once again the same question, find the position where zero potential point is obtained or neutral point for potential is obtained. So these two numericals you have to solve at your home and try to, we can say, they obtain the answer. Now we'll discuss few more. Now whatever the numerical we would like to discuss, it is very important for JEE NEET, especially I can say that NEET base. No doubt easy, but try to solve it. Here this type of the regular hexagon is given. Ready? Regular hexagon is given, and at each vertex Q amount of charge is placed. Here length of side, it is 5 centimeter. Okay, and the charge here given 1 microcoulomb. Whatever the charge here, the 1 microcoulomb charge is placed at each and every vertex of this regular hexagon. So what is the net potential at the center O of this hexagon? Think about it. Start. We make correction so that this numerical become very easy. Here 10 microcoulombs. You can see that 5 centimeter, 10 microcoulomb. Okay, so what's the answer? We check it. First of all, you can see here 6 charges. What is the formula of potential? First of all, think about this first charge. This charge producing potential here at this point O. What is the formula of potential due to single charge or point charge? You know that potential due to point charge, it is kq by r. Ready? So here, first of all, r, this is the r distance, but you know that this is the regular hexagon. So obviously these all the distances are equal. So these are the equal distances as per geometrical concept, or because of the, we can say, the geometry of the diagram. So here you can see that r remain constant for each and every charge. That means I can say point O situated at equal distance from the 6 vertices or 6 charges. So distance remains same. Check the charge. Charge also same. So one point is clear. Charge same, distance same. That means whatever the potential produced at this point O because of these 6 charges will also remain same. That means the net potential at point O is V net is equal to, I can write 6 times of V, where V is the potential due to one charge, but it is 6 times. You can also write kq by r plus 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 kq by r. If you have enough time, there is no other work, then you can spend some time here. Don't worry. So here 6. What's the, we can say that V potential due to charge kq by r. So 6. What's the k? 9 into 10 raised to 9. What is the charge? 10 micro. So minus 6. What is the distance? Distance already 5 centimeter, because you know that this is the equilateral triangle. So this is r also 5 centimeter. This is the very interesting point. So 5 centimeters. So 5 into 10 raised to minus 2. So if you simplify, so you can see 5 2 ja 10, here 6 9 2. So 9 2 ja 18, 6 ja 108. So 108. Here 9 minus 6, that means 3 and 2, so 10 raised to 5. So now you can think about, we can say that answer point. So it is 1.08 into 10 raised to, you know that 3. But okay. So V net, and this is, you can see that volt. A similar type of question you have to solve now. This is, you can see that hexagon. What happen in this type of numericals? Generally they provide 2 points always in the form of common. For example, charge and distance. नंबर चेंज होते जाएंगे. इधर 6 है, कभी कभार आपको पेंटागन देंगे, सिनारियो चेंज करने के लिए स्क्वायर देंगे. तो ये सब सिचुएशन रिलेटेड न्यूमेरिकल देने जा रहा हूँ. बहुत ही बेस्ट है ये, तो ठीक ठाक है. ये आपका एक अनसोल्ड है. This is your 2 point, we can say the 12, but it don't, sorry, 2.13, but don't worry. Sorry, 2 point, this is your unsolved number 2.2. Don't worry. But this is unsolved number. But now, whatever the numerical we would like to solve, it is, we can say that one of the most time के, और ये से question है वो local level examination गुजसेट में भी है, वो नीट में भी है. So just try to solve it. Now this type of cube is given. Ready? So 8 vertices. So obviously 8 charges are placed at this 8 vertices, and length of side is b. Length of side is given b. What is the total potential at the center of a cube? This is your question. Total potential at the center of cube. Take your time and try to solve it. Okay. Here, whatever the answer required, it is required in the form of pi. Don't forget, because ज़्यादातर ऐसे न्यूमेरिकल में ऑप्शंस है वो पाई के फॉर्म में देंगे. Okay, friends, so just concentration required. What happened here? Instead of hexagon, now there is a cube. Recently, we have discussed this type of numerical, and at that time, I gave one hint. You know that 6 charges, same magnitude, same distance. Here, same scenario, 8 charges, same magnitude charges. Check the distance. We would like to think about distance of this central point from each and every vertices. So it remains same. So how can you find? We can say the distance. We have idea about the potential due to one charge. It is kq by r. Here no problem about charge because the magnitude of charge remains same. So now we have to think about only r. What is the distance? Because here length of side is b. So most of students have idea about it. You know that. If you have no idea, then remember, whenever you are dealing with cube, then what is the, we can say that the length of longest diagonal. Anybody? You know that what is the length of longest diagonal? Longest diagonal length always equal to root 3 times of length of side. So first of all, longest diagonal, that means this distance already root 3. This is your, we can say, the center of. So this is root 3 multiplied by length of side b. So this entire distance is root 3b. Ready? But we are thinking about this point. So what is this distance? It is central point. So first of all, I can write length of longest diagonal of cube. It is root 3 multiplied by length of side. So here length of longest diagonal of cube, or I can write given cube, it is root 3 multiplied by b. So this distance root 3b, but this is not your requirement. Your requirement to find only the distance of this charge from central point, or distance of central point from this charge. So what is this distance? Obviously it is root 3b by 2. So already we have idea about r now. So what is the total potential at center of Q? It is V net. So we know that V net is 8 times of simply KQ by R. Check the previous numerical. In previous numerical hexagon, so we multiplied 6 times of KQ by R. Now here 8. So 8. What is the K? 1 upon 4 pi epsilon naught. मैं पहले बोला इसमें पाई के फॉर्म में ऑप्शंस देंगे. So Q R already with us, it is root 3b by 2 R, root 3b by 2, this distance already R. Now you have to simplify this portion, so you can see that 2 to the 4. So final answer, sorry, here directly we can think about, first of all, 2 will move from denominator to numerator, that means numerator. So 8 to the 16 divided by 4, that means 4. So 4 cube upon root 3 pi epsilon b. That's your net potential, most IMP. This is the numerical very important, 4q upon root 3 pi epsilon b. So your answer should be required in the form of pi. तो ऐसा ऑप्शन देंगे आपको. This is also very important numerical. This is in, we can say that in your additional exercise. Okay, so just concentrate on this type of numerical. Now friends, I can say we have discussed important points, no doubt, but we'll move towards the next segment. Next segment very IMP, but whatever the next segment, it takes some, we can say that some, we can say fundamental test from your side. So you have to analyze this each and every formula. घर पे सब कुछ वापस एक बार देख लो, हर एक न्यूमेरिकल को अपने आप देखो. आज से अपन लोग होमवर्क सिस्टम में जा रहे हैं, तो आज आपको मैंने जितने न्यूमेरिकल्स करवाए और एक मोस्ट टाइम की थियरी करवाई पोटेंशियल ड्यू टू चार्ज, वो 2 टाइम्स लिख के थियोरेटिकल पोर्शन को मैं लिखने के लिए बोलूँगा. बाकी सब न्यूमेरिकल्स की प्रैक्टिस करनी है. और ये मंडे ट्यूसडे अपना जो टेस्ट होगा वो होगा न्यूमेरिकल और थियरी का टेस्ट मंडे, और नीट का टेस्ट होगा ट्यूसडे, नीट जेडबल. सो प्रिपरेशन शुरू. होमवर्क आपने जो किया उसका चेकिंग के लिए आपको जिसे कह सकते हैं कि मैसेज आएंगे. सो आज के लिए इतना काफ़ी है. ये दोनों लेक्चर्स को आज अच्छी तरह एनालाइज करो. इसके रिलेटेड एक असाइनमेंट भी वेबसाइट के ऊपर अपलोड किया जा रहा है, वो भी आपको जिसे कह सकते हैं जैसे ही लेक्चर खत्म होता है वो भी आपको देखना है. उसमें मैंने बहुत इंपॉर्टेंट यानी कि जो डिस्कशन हमने किया उसके रिलेटेड 10 से 12 MCQs रखे जो आपको प्रैक्टिस के लिए. थैंक यू वेरी मच.